In this video we are going to talking about how to balance a half reaction. There are few rules we have to follow. First one is initially write the redox reaction that should be balanced. In this example I am going to take permanganate ion MnO4 minus becomes Mn2 plus in acidic medium. This is the redox reaction we need to balance right now. Second rule is balance element whose oxidation state is going to be changed. Now we have to consider about the oxidation state of manganese in both sides. In left side you can see manganese take plus 7 oxidation state, and this manganese shows plus 2 oxidation state. But you can see in both sides there are only one manganese atoms, so we don't need to balance manganese. So we can write down the redox reaction like this there with no changes. Our third rule is balance oxygen in both sides. For balancing oxygen we have to add H2O molecules in suitable side. Now consider about this our previous example. In this example you can see left side there are 4 H2O molecules, oxygen atoms, so we have to use 4 H2O molecules into the right side. Now you can see oxygen is balanced. Then we need to go to our fourth rule. Fourth rule is balance hydrogen in both sides. For balancing hydrogen we have to add H plus into suitable medium. In this side, right side, you can see 8 hydrogen, but in left side there are no hydrogen, so we have to add 8 H plus into left side. Then this is the reaction after balancing hydrogen and oxygen. Now we need to balance only charge in the both sides. Our last rule of balancing half reactions is balance charge in both sides. For balancing charge we have to add electrons into the suitable side. Now consider about the charge of both sides. In this reaction now we know hydrogen and oxygen is balanced, so right side charge is plus 2 and the left side charge is plus 7. So we have to add 5 electrons because electron takes minus 1 charge. So 5 electron takes minus 5. So total charge of this left side is now plus 2. In the second example we need to balance manganate ion MnO4 2 minus, MnO4 2 minus Mn2 plus. This is the reaction we have to balance. In acidic medium MnO4 2 minus becomes Mn2 plus. So we don't need to balance manganese. In both sides there is only one manganese atom. So this is the reaction we have to balance in the acidic medium. First of all we have to balance oxygen. For balancing oxygen we have to add 4 H2O molecules. Then now you can see oxygen is balanced. After that we have to balance hydrogen. For balancing hydrogen we have to add 8 H plus into the left side. Then this is the reaction after balancing both oxygen and hydrogens. Now you can see in both sides manganese, hydrogen and oxygens are balanced, so we have to balance electron and the charge in both sides. First of all we have to consider about the charge in right side. Right side you can see charge is plus 2 and this side charge is plus 6, so we have to add 4 electrons to balance the charge in both sides. In the third example we have to balance MnO2 becomes Mn2 plus in acidic medium. We know MnO2 is a brown precipitate, so that becomes colorless when this reaction happens. First of all, we have to balance manganese because manganese oxidation state is going to be changed. Both sides we can see only one manganese atom, so we don't need to balance manganese in this reaction. And then we have to balance oxygen. For balancing oxygen we have to add H2O. So we have to add two H2O molecules into the left side. After balancing oxygen we have to balance hydrogen in both sides. You can see in right side by now there are 4 hydrogen. There is no hydrogen, so we have to add 4H plus. For balancing hydrogen we have to add 4H plus into left side. After adding 4H plus, this is the reaction. 4H plus MnO2 becomes Mn2 plus and 2H2O. Then finally we have to balance the charge in both sides. Now we need to balance the charge in left side. You can see charge is plus 4. In right side the charge is plus 2. So we have to add 2 electrons into the left side of the reaction. After adding 2 electrons, this half reaction is already balanced. In this example we have to balance dichromate become Cr3 plus. First of all we have to balance the element whose oxidation state is going to be changed. You can see oxidation state of chromium is going to be changed, but in left side there are 2 oxygen atoms. In this side there is 1 oxygen atom, so we have to balance chromium initially. To balance chromium I have to add 2 in front of Cr3 plus. After adding 2 in front of Cr3 plus, chromium is balanced now, and then we have to consider about oxygen. For balancing oxygen we have to add 7 H2O molecules into the right side. Then oxygen is balanced. Then we have to balance hydrogen and the charge of this reaction. For balancing hydrogen we have to add H plus into the suitable side. In this reaction we need to add 14 H plus into left side. Then this is the reaction after balancing chromium, oxygen and hydrogen. Then we need to balance the charge in both sides. First of all, consider about the charge in the right side. Charge is plus 6 and the charge of this left side becomes plus 12. So we have to add 6 electrons into the left side to balance the charge in this reaction. In this reaction we have to balance CrO4 minus becomes Cr3 plus. We need to balance this half reaction. You can see in both sides chromium are balanced. There is 1 chromium atom and chromium is going to change its oxidation state. Its oxidation state change from plus 6 to plus 3. So now you can see chromium is no need to balance. We have to balance oxygen and hydrogen and the charge of this half reaction. As we have done in our previous examples, we need to balance oxygen in this step. So we need to add 4 H2O molecules to balance oxygen because there are 4 oxygen atoms in the left side. After balancing oxygen, we have to balance hydrogen. In this step, to balance hydrogen, we have to add hydrogen plus ion into the suitable side. For that, we need to use 8H plus into the left side. After adding 8H plus, this is the reaction. 8H plus plus CrO4 minus becomes Cr3 plus and 4H2O. Then finally we need to balance the charge between both sides. After balancing oxygen and hydrogen and chromium, we need to consider about the charge. You can see this side takes plus 3 charge and this side takes plus 6 charge. So we have to add 3 electrons into this side. This is the reaction after adding electrons to balance the charge. 3 electrons plus 8H plus and CrO4 2 minus becomes Cr3 plus and 4H2O molecules. Now we need to consider about this example. This reaction happens in basic medium. Cr3 plus becomes CrO4 2 minus. So we need to find the element which oxidation state is going to be changed. Chromium oxidation state is going to be changed from plus 3 to plus 6. So we need to balance chromium. You can see chromium is already balanced. So this is the reaction we have to balance right now. And then we have to balance oxygen and thereafter hydrogen and charge of both sides. In the right side you can see 4 oxygen atoms, so we have to use 4 H2O molecules into the left side to balance oxygen, and thereafter we have to use H plus to balance hydrogen. In our left side you can see 8 hydrogen atoms, so we have to use 8 H plus into the right side. To balance hydrogen we have to add 8 H plus into the right side. Then after we have to balance charge in both sides. Let's consider about the charge in the left side. Left side charge is plus 3 and right side charge is plus 6. So we have to add 3 electrons into the right side to balance the charge. In the base medium, MnO4 minus becomes MnO2. When we consider about the color changes, MnO4 minus color is purple and the MnO2 is a brown precipitate. So oxidation state of manganese is going to be changed, but manganese is already balanced in both sides. So this is the reaction we have to balance. Firstly we have to balance oxygen and thereafter hydrogen and finally electrons, that means charge in both sides. MnO4 minus becomes MnO2. You can see in left side there are 4 oxygen atoms, in right side there are 2 oxygen atoms, so we have to use 2 H2O molecules into the right side to balance the number of oxygens. Thereafter we have to balance hydrogen. For that we have to use 4H plus into the left side of this reaction. After adding hydrogen plus, this is the reaction 4H plus plus MnO4 minus becomes MnO2 plus 2 H2O molecules, and thereafter and finally we have to balance the charge in both sides. And this is the reaction we have to balance the charge of both sides. You can see in right side the charge is 0, but in the left side the charge is plus 3, so we have to add 3 electrons into the left side to balance the charge. Then this is our final balance half reaction. 3 electrons plus 4H plus and MnO4 minus becomes MnO2 precipitate and 2 H2O molecules. We know the color of MnO2 is brown. It is a precipitate. And MnO4 minus color is purple color solution. Now we need to consider about IO3 minus. Iodate ion becomes I2 in the acidic medium. First of all we need to balance the iodine because iodine oxidation number is going to be changed, so we have to add 2 in front of IO3 minus. Very simply, now you can see iodine is balanced. There are 2 iodine atoms in both sides, and thereafter we have to balance number of oxygen, number of hydrogen and the charge in both sides. Now we need to balance number of oxygens. For balancing number of oxygens we have to add H2O. In left side you can see there are 6 oxygen atoms, so we have to add 6 H2O molecules into the right side. Thereafter we have to balance number of hydrogen in both sides. In our right side, right now we have 12 oxygen hydrogen atoms, so we have to add 12H plus into the left side of this reaction, because balancing hydrogen we have to use hydrogen plus. Now you can see this reaction is already balanced with iodine, hydrogen and oxygen. Then we need to balance the charge of this reaction in both sides. Our final task is to balance the charge of both sides. You can see there are 0 charge in our right side. Also in our left side you can see the charge is plus 10. So we have to use 10 electrons into the left side of this reaction, then we can balance the charge of both sides. So this half reaction is a reduction half reaction of IO3 minus. Now we need to consider about the decomposition reaction of hydrogen peroxide. When the decomposition happens, H2O2 becomes H2O and oxygen gas. So this is a disproportionation reaction. There are 2 half reaction like reduction and oxidation. First of all, this is the half reaction we are going to consider about. Hydrogen peroxide becomes H2O. We need to balance the oxygen, because oxygen oxidation state is going to be changed in this half reaction, so we have to add 2 in front of H2O. Now oxygen is balanced, then we have to balance hydrogen in both sides. So you can see in right side there are 4 hydrogen atoms, and in left side there are 2 hydrogen atoms, so we have to use 2H plus into the left side of this reaction. Now consider about the charge. Left side charge is plus 2 and the right side charge is 0, so we need to add 2 electrons. So this reaction, this half reaction is a reduction reaction. Then we need to consider about the oxidation reaction of this disproportionation reaction.